afternoon, everyone. I know it is 2 minutes to 3 o'clock. I just want to make sure that everybody is all right and prepared to start with today's session. We're going to start exactly at 3 with the content. So if you have any question relating to the past sessions that we did or anything you want to ask, now you have that chance before we start with the session, because when I start with the session, we're only going to concentrate on doing the hypothesis testing. So welcome to your online session in May, your first one in May. If you have any question or you want me to respond to something, or feel free now to ask.
Good afternoon to you.
Thank you. And remember that the sessions are interactive, so feel free to ask any question while we're busy. And I will urge you to please participate in the discussions or when we're doing exercises as well. The sooner someone does something, the better we use up the time, because if you stay quiet, we stay longer and the minutes on the clock ticks. Okay, so it's 3 o'clock and welcome to your online session. I hope you have your statistical tables with you as well, because we're going to continue using them. And make sure that your microphones are always on mute. And please switch off your videos. Can you also please turn off your video? And make sure that your microphones are on mute. Thank you. So let's do hypothesis testing. The first hour, we're going to look at 30 minutes. We look at the basic concepts, and then we start looking at hypothesis, doing examples of hypothesis testing for the mean. And the first part we will do when the population standard deviation is given, like we did with the confidence interval. With this as well, we will continue with those concepts. We look at when the population standard deviation is given or known, and then we'll take a break. We'll come back. We'll continue with the hypothesis testing for the mean, but this time we will look at when the population standard deviation is unknown. And then the last bit of it, we will look at doing hypothesis testing for the proportion, and then that will conclude today's session. So, what is hypothesis testing and why do we need that? That's what we're going to start learning about. The basic principles of hypothesis testing. What is hypothesis testing? A hypothesis testing is a claim that the researcher wants to test. So, if the researcher wants to test something, therefore it means there should have been some studies before, and they would have collected the data from the population and found that. Because when we test the hypothesis, we're always going to infer back to the population of our interest, because we're going to be using the sample statistics to calculate that. Always, it means when you test the hypothesis, it means you need to always state it in regard to the population parameter. In this instance, it will be the mean, or it can be the population parameter for the proportion. For example, for the mean, we will say the mean monthly cell phone bill in the city is 42, which is the mean will be your mu, and we'll never use the sample statistics to represent the hypothesis. Okay. So since the hypothesis is about testing something or wanting to test if the assumptions of those things are true or not, Therefore, it means you need to state your null hypothesis, which will be the thing that you want to test. And please make sure that you mute your microphones. And then you will also need to state your alternative to that hypothesis. So the first thing you need to know about stating the null hypothesis is the following. The null hypothesis is the claim that needs to be tested. It's the thing that we're going to say we are rejecting or we are accepting at the end. And remember, we said we always use the population parameter. For example, this says the mean diameter of a manufactured bolt is 30 millimeter. Therefore, when we state the null hypothesis, our null hypothesis will say the mean is equals to 30, because that's what we want to test, that the mean diameter is 30. When we state the null hypothesis, there are things that you always also need to remember. We use only the population parameter, like I said in the beginning, not the sample parameter. So the correct way is always going to be the mean, which is the parameter mu, not the x bar. We don't use the x bar. We always use the population parameter, mu. We're always going to begin with the assumptions that the null hypothesis is always true, because it's similar to the notion you are guilty until you are innocent until proven guilty. And that's what you need to always remember, that your assumption will always state your null hypothesis is true, and that is what we want to check whether is it true or not. And always remember that when you state your null hypothesis, there should always be an equal sign to your null hypothesis. There is an equal sign. So it's either you say it's equal or less than or equal or greater than or equal. There should always be an equal sign. But most of the time, it doesn't really matter whether you put the equal sign there or the less than or equal or the greater than or equal, as long as there is a null hypothesis that states that something is equal, whether it's greater or less. However, you still need to know the sign, which is equal, so that you know which test you're doing, because those signs, they do determine whether are you doing a one-tailed test or a two-tailed test or a three. Only those, a one-tailed test or a two-tailed test. So you need to state whether is it equal or not equal. And your null hypothesis is the one that we are going to reject or not reject. And we will look at it at the later stage when we do the hypothesis testing. So what will be the alternative to this? If I know that my null hypothesis is the claim that needs to be tested, what is my alternative? Then my alternative will be the opposite of my null hypothesis, will be the claim that I don't want to test. But if my null hypothesis is not true, then it means my alternative is true. For example, the average diameter of the manufactured bolt is not equal to 30 millimeter, because in my null hypothesis, I said it was equal to 30, but this one can say it is not equal to 30. Therefore, that is my alternative, and I also still use the population parameter. Please make sure that you are always muted when you join the sessions. And your null hypothesis, your alternative hypothesis does not have an equal sign. So it means you can never put an equal sign to the alternative hypothesis. It will always have the not equal, or it will have a less than, or it will have a greater than. And those we use to determine your region of rejection, or it's the one that it's going to tell us, especially whether we're going to do a one-tailed test or a two-tailed test. And we will use the alternative to do that, because the sign you put on the alternative is the most important sign of all. Okay. And we don't even have to prove the alternative because we always have to prove the null hypothesis. And in a nutshell, this is always what the researcher proves or what the researcher wants to prove, because that is what we use to go and find the critical values. We go use this to say whether we're doing a one-tailed test or a two-tailed test. When we do the hypothesis testing, there are a couple of errors that can happen. So there is what we call a type 1 error. A type 1 error is an error that occurs when we reject the null hypothesis, even though it is true. Because based on what the researcher wants to prove, in your null hypothesis, if the researcher wanted to prove that the mean is greater than, we cannot put it in the null hypothesis, we're going to put it in the alternative. But when we do the test and we found that the mean is not, then it means we still we're proving something that we're rejecting the true null or the true hypothesis that we were supposed to be rejecting. And this is what we call a false positive. The biggest problem that arises from those, like your type 1 error, it is when your sample data contains misleading information due to the sampling error. So when you collect your sample, those sampling errors might lead most of the time to your hypothesis, to getting a type 1 error on your hypothesis testing. The other type of an error that you can get is a type 2 error. And a type 2 error occurs when the null hypothesis is not rejected, even if it is a false null hypothesis. So if you fail to reject a false null hypothesis, then you are committing what we call a type 2 error. And the type 2 error has the probability of beta, which is the probability for a type 2 error. And the probability for a type 1 error, it's called the alpha, and it's also called the level of significance. And this is always set at the beginning by the researcher, which is your type 1 error probability. So when you do the hypothesis testing, there are several steps that you need to know and master, because let's say, for example, in the exam, they are going to ask you a question about hypothesis testing. The reality is they are going to ask you in the options, all the options that they give you will lead to you knowing all 6 steps of a hypothesis testing. And what do I mean by those 6 steps of hypothesis testing? And those steps are, the first step is for you to be able to know how to state the null hypothesis and the alternative hypothesis. Like we did in the beginning.
Guys. Oh, kamu secret lama. I know it's
Please make sure that you mute your microphones, because then you're disturbing the whole session. So you state your null hypothesis and your alternative hypothesis, like we did in the previous examples that we did there, where we stated the null hypothesis and the alternative. We said the mean is equal, the mean is not equal. And those are the things that you need to state in the beginning. Number 2, since they will give you several things in order to help you do the hypothesis, you need to state what you are given, especially in terms of the level of significance and your sample size. If you know those, then you are going to use them to help you find the critical value or to make conclusion at the end. For example, the sample size, you will use it for knowing whether the population is bigger or not, or things like that. But always when you do the hypothesis testing, the assumption is your population is normally distributed. And if the population is not normally distributed, then the N should be greater than 30. And that's the assumption for you to do the hypothesis testing. Then step number 3 is for you to determine what kind of a test are you going to do. Is it a t-test or is it a z-test? Depending on what you are given. For example, if you are given the population standard deviation, we know that we're going to use a z-test. If we are not given the population standard deviation, they will give us the sample standard deviation. Therefore, it means we use the t-test, like we did with the confidence interval. The same concept happens here. So either you do the Z or you do the t-test. Step number 4, you're going to, since you know that you're doing a Z-test, you're going to find the critical values on the Z table. If you are going to do the t-test, you're going to find the critical values of t on the t table. But also, depending on your alpha, it will also determine whether you're going to be finding two regions of rejection, because we use the critical values to define the regions of rejection. And also, depending on your alternative sign you used, whether it's not equal or it is less than or it is greater than, those will depend on what kind of a critical value you're going to be looking at. For example, if you are doing a two-tailed test, then it means you're going to divide your alpha by 2 to find the critical value, and then you go find the critical value on the table. If you are doing a one-tailed test, then you only say your alpha, which you already defined in number 2, and you go to the table to go find the critical value. So you need to know all those things, because step number 1 and step number 2, they also give you a way of what needs to happen next. So after you found your critical value, then you can calculate your test statistics, because you need to calculate that in order for you to know whether does that test statistics fall in the rejection area or outside of the rejection area, based on the decision that you will make, based on the decision of the critical values, based on the decision of the alternative or the null hypothesis and the alternative sign that you use. Once you have calculated the test, then you can make a decision. And then after you make a decision, you can conclude. And when you are concluding, you can either reject or do not reject your null hypothesis. And that is the statement that you're always going to say. You do not reject or you reject the null hypothesis because there is sufficient evidence or there is no sufficient evidence that the true mean is equals to or the true mean is less than, something like that. Let's look at the critical value and the rejection area. So let's say we state the null hypothesis as for a two-tailed test, therefore it means your alternative hypothesis will be the mean is not equal. And therefore, the minute you put not equal, then it means you are doing a two-tailed test. And when you are doing a two-tailed test, therefore it means you will have two rejection areas. Whether you're doing for T or you're doing for Z, this was supposed to be a T. So whether you're doing for T or you're doing for Z, that should be two rejection area. Anything that falls within the rejection area, the blue area there, you will reject if you are doing a two-tailed test. Anything in the white area in between, you do not reject. But because your Z value, you only find one Z value. So you're going to check if my Z value is minus what number and it falls within this, then you're going to reject. If it's minus or if it's positive, but it falls in this rejection area, you reject. So you're looking at that Z value, you're going to reject or do not reject your null hypothesis based on that. That is for a two-tailed test. When we look at a one-tailed test, it means we only have one area of rejection. So for example, for this first one, the rejection area is on the left-hand side, which we call it the negative side of the rejection area or the less than. Because when we look at the alternative, remember the null hypothesis always have an equal sign. We can write it as greater than or equal, or we can just write it as an equal sign. It doesn't really matter. What matters the most is the sign that goes on the alternative hypothesis. The minute it says it's less than, therefore it means our critical region of rejection will be on the less than side, and anything that falls in the less than on the blue area for that alpha. And now here is the thing. Let's go back to the two tail. If you look at the two tail, our alpha, we're always going to divide it by 2 because we're looking for the 2 rejection area. When it's a one tail, we do not divide the alpha by 2. We leave alpha as is, and we're going to find the critical value on the Z table. If it's the T table, we're going to find T alpha and the degrees of freedom. Remember, your degrees of freedom is n minus 1. The same thing that we did. But remember, on the confidence interval, we were dividing it by 2 because there were 2 sides. On hypothesis, for a one-tailed test, if it's a one-tailed test and the sign says less than, we only use alpha. We don't divide alpha by 2. So we're going to find alpha on the Z value, or we're going to find alpha degrees of freedom on the T table for the T critical values. And we make the decision. Same applies to the upper tail area. With the upper tail area, whether in the alternate or null hypothesis we put the less than or we put the equal sign, it really doesn't matter. What matters the most is what goes onto the alternative, because the sign that goes on the alternative will tell us where is our region of rejection, and our region will be on the upper tail, on the right upper tail, and it will tell us anything that falls on the blue area we reject. Otherwise, anything that falls on the right, on the left, we do not reject. On the white area, we do not reject. And that's how you're going to make the decision on whether you are rejecting the null hypothesis or do not reject the null hypothesis. And based on those. So, and that concludes our first half of the session, which talked about the basic concept that you needed to know. Remember, to find the critical values of T for a one-tailed test, we use alpha and the degrees of freedom. And our degrees of freedom is n minus 1. Any other question? Do you have any question based on what we just did? If there are no questions, then we can move to the next section. Remember to put your student number on the chat. Don't forget to put your student number on the chat group. No questions? If there are no questions, then we can continue. Any question? Okay, if there are no questions, please remember also to mute your microphones. Then we can look at doing a hypothesis testing for one sample test when the population standard deviation is known. The other thing I need to also mention is in your modules, you do not cover everything that is covered in the prescribed test book. Everything that is covered in your prescribed test book is not covered in your module. So please, when you go through your prescribed test book, please look at also the content of your study guide where it gives you which sections you are covering, because you don't do everything. For example, we only do a hypothesis testing for one sample test. And in your test book, they might have another hypothesis testing for 2 sample tests. You do not cover that because it does not apply to you. They might be covering other tests that you do not do. You only do hypothesis testing for one test where the population standard deviation is known and when the population standard deviation is unknown. You need to look at only those. And then the other last thing is the hypothesis testing for one sample test for the proportions. Those are the only 3 sections that you need to look at.
We were sent an email at the beginning of the year telling us what will be covered.
Yes, some modules they do that, like 1510. I know that they do tell you, and they also do specifically tell you which company or which section of the prescribed book you need to look at.
Yes.
Yes.
Yeah.
Okay. All right. Okay, so let's do the hypothesis testing. So this section, we're going to look at doing the hypothesis testing when the population standard deviation is known. So it means they will give us the population standard deviation. And when that is done, when they give us that, we should always know that we're going to be using a Z test statistic, which is the Z test, which is the same as what we use in the sampling distribution. Remember when we calculated the probabilities for the sample distribution, we said we use a Z-score, and that Z-score is called the Z-test. Here, when we do the hypothesis testing, we use the Z-stat, and that is the formula you will get in the exam. So it means when they ask you any question on the sampling distribution, do not be alarmed when you see Z-stat formula without seeing just the formula without a Z. They mean one and the same thing. So you will get this formula, not the one without a Z-stat. You will get the Z-stat formula, and you know that you use it in the hypothesis testing, and you also use it for sampling distribution. You need to always remember that. And that is the formula we'll use when we calculate the test statistic. Okay, so remember the 6 steps. State the null hypothesis, alternative hypothesis still applies because these are the base for what we need to be doing. We need to identify what we are given, and which is the alpha and the n, sample size and level of significance, and then state what test we are doing. So if we are doing for the proportion, for the mean, when the population standard deviation is given, therefore it means we're using the Z-test. And then we're going to find the critical value, so therefore it means we're going to find them on the Z table and create our region of rejection. It's always good to do the region of rejection as a graph, so it makes it easier for interpretation instead of you remembering all the weightings. If the Z-stat is greater than the critical value, we reject, or if it's less than the critical value, we reject for two-tailed test. You want to remember all this, but if you draw a diagram, you will clearly define your rejection area, and it's always easy to identify them. So I always use the graph. So, and then you're also going to calculate the test statistics by calculating the Z-stat, and then we make the decision and conclusion at the end. Okay, so let's look at an example. Let's say we want to test the claim that the true diameter of the manufactured ball is 30 millimeter, assuming that the population standard deviation is 0.8. Therefore, they've given us the population standard deviation. Therefore, it is known, and then it means we're going to be doing the Z-test. Yay, yippee. Our alpha is 0.05, n is 100. Step number 1, we state the null hypothesis and the alternative hypothesis. The mean is equals to 30. The mean diameter is not equals to 30 because the test is just said, test the claim that the diameter is 30. Therefore, it means it's equal. And then when it's equal, the alternative will be not equal. And therefore, it means here we're doing a two-tailed test. It means we're going to find two regions of rejection by using the critical area, the critical value. Step number 2, state what you are given. We know that we are given our n and our alpha. Our alpha is 0.05 and our n is 100. That's what we are given. Step number 3, we determine the appropriate test. We know that our population standard deviation is given. Therefore, it means we are going to do a Z-stat. That's as simple as that. Determine the appropriate technique you're going to use or the test statistic you're going to use. We're going to be doing the Z-test or the Z-test statistic. Step number 4, we need to go find the critical value. Our alpha was 0.05. We are doing a two-tail, therefore it means our critical value, we're going to find it on the Z table. Remember, it's a two-tail test. So our Z will be alpha divided by 2, which is Z 0.05 divided by 2, which is equals to Z of 0.0250. I don't have to stress it that much because by now, since from the beginning we started working with critical values when we were doing the confidence intervals, by now you should know that for alpha divided by 2, where it's 0.025, on the Z table, it will be equals to 1.96. But I'm not going to make that assumption. I'm going to help those who still don't know how to do that. So to find the critical value, we know that our Z alpha is 0.025. So we go to the Z table. And go to the table. Which table? I'm going to come to the table and go to the positive or negative side because the negative side has the 0 probabilities. Remember that we're looking for Z. We're looking for Z 0.0250. And we know that the Z, we know that this is the probability, so it means we find it inside the table. We look for 0.0250, and that is the value that we're looking for. So to find the critical values, we move out, and we find that critical value is 1.9, and we go up to the last digit, and our last digit is 6, and that is 1.96, and that is the value of our critical value. And once we have the value of our critical value, which is 1.96, then we can calculate step number 5. It says compute your test statistic. Collect and compute your test statistic. And to do that, we know that our N was 100. Let's say our sample mean, they will give you in the beginning in the question, your sample mean is 29.84. And we know that our population standard deviation was known and it was 0.8. Then we substitute into our Z-stat table, our test statistic. So Z-stat, sample mean minus population mean divided by the standard error. Then we substitute our mean is 29.84 minus the population mean, which was stated in the null hypothesis. It's 30 divided by the standard deviation divided by the square root of 100. The top part we get minus 0.16, 29.84 minus 30 is minus 0.16. 0.8 divided by the square root of 100 gives us 0.08. We divide the two and the answer we get is minus 2.0. And that is our Z test. And we can take the Z test and make a decision. Making the decision based on the critical values where we define our region of rejection. Remember, this is our critical value. We defined it as 1.96. So it means because we're doing a two-tail test, we'll have the region of rejection on the negative side and also on the positive side because it's a two-tail test. The blue area is our region of rejection. Therefore, it means if our Z test falls in the white area, we do not reject. If it falls on the blue area, we reject the null hypothesis. So where is our Z? Based on the decision, if it falls on the red, on the blue, which is if Z stat is less than minus 1.96, which is the blue side, or if it falls on the blue side, which is more than 1.96, we reject the null hypothesis. Otherwise, if it falls between in this white area, we do not reject the null hypothesis. And boom, our Z stat, it's minus 2.0, which means it falls in the blue area. It is less than our critical value of 1.96. So the test statistics is in the rejection area. Therefore, it means in our conclusion, we can decide and conclude that we reject the null hypothesis and conclude that there is sufficient evidence that the true mean diameter of the manufactured board is not equal to 30. Because we're rejecting the hypothesis, the null hypothesis of mean equal to 30. And that's how you do the test, the hypothesis testing. Any question? If there are no questions, then we can look at...
Sorry, Elizabeth, can you please repeat the last part, number 6? Can you please repeat it?
Number 6, you created the rejection areas by using the critical value, and we found the critical values as that. So if I go back. So we defined our critical value. We set our critical value, that critical value, we set it 1,96. We come here, we define it because we are doing a two-tail. So there will be a negative side and the positive side. And with that, now we go and look at our Z test. Our Z stat, remember we calculated it and we found that it was minus 2.0. Where does that fall? This is minus 1.96, therefore it means our Z, this is the same thing that I just repeated. Our Z stat falls here in the blue area. And since our Z stat falls in the blue area, it means we reject the null hypothesis because it falls in the rejection area. And in conclusion, we just repeat the same thing that I just said. Reject the null hypothesis and conclude that there is a sufficient evidence that the mean diameter is not equal to 30 because we are accepting the alternative. Remember, the null hypothesis was the mean diameter is equals to 30. So we rejected that. Therefore, it means in conclusion, we can safely say there is sufficient evidence that the mean diameter is not equal to 30. And with that,
where did you get the sample mean?
They will give it to you because this is an example. Yes. In the statement, they will give you all the information you will need to answer the question. Like your sample mean, you will not make it up on the fly like I'm making things up on the fly. They will give it to you like right now. They gave you the sample mean in the question, so you are not going to have to calculate it. But sometimes you will have to calculate it if they give you the data. Okay, so this is the exercise. The first step is to state your null hypothesis. Please do not use the options. Let's not look at the options. We're going to do the 6 steps of hypothesis testing. So step number 1, you're going to state the null hypothesis and the alternative hypothesis, which they already did for you. So that's step number 1. State your null hypothesis and your alternative. Step number 2, what are you given? What is your N and what is your alpha? Step number 3, which test are you doing? What is this test that you're going to be doing? Step number 4, find the critical value. Step number 5, calculate your Z stat, which is, remember your critical value is based on what the test is. Z stat is the sample mean minus the population mean, which is always given in your hypothesis testing, in your null hypothesis or your alternative. Divide by the standard error. And since this exercise is for where the population standard deviation is given, because they have given you the population standard deviation. So all the information you need to do this are given. And once you are done, then you can make your decision and conclude. Number 6, make your decision and conclude. I've already given you the high level step. So that's your exercise. You have until, let's say, quarter to. Easy to calculate. Until quarter to, then we recap. Because we have a break after this.
May I please ask a quick question?
Hello, Mrs. Elizabeth. Your sound is off. You're on mute.
So we can do the same by finding the p-value. By using the p-value, we can also make conclusions. If the p-value is less than alpha, we reject the null hypothesis. And we can do so by looking at the 5 steps as well. You state your null hypothesis and your alternative. Choose level of significance and the sample size. You determine the appropriate test and the sampling distribution. You collect and compute your test statistic and your p-value. We make the decision based on the p-value and the alpha level of significance, and we can reject the null hypothesis. So how do we do that? Using the same exercise that we did. So we take the test wants to claim that the mean is 30, is equals to 30, the population mean is 30. We state the null hypothesis, the mean is equals to 30, the mean is not equals to 30. We state what we're supposed to be given, alpha 0.05 and 100. We're doing a z-test, therefore it means, because we're also doing a two-tailed test, it means we're going to find the z. When we go find the p-value, we're going to be looking for two sides for the p-value on the z table. Then we have all the information that we need, the n, the mean, sample mean, and the population. We calculate, we know that we calculated this and we found that it's -2. To go find the population mean, to go find the p-value, we do the following. To find the p-value, if it's a two-tailed test, we're going to find two sides of the p-value. So we take our z value of 0.2, we go to the z table. I'm going to keep all this. We go to the z table. We know that we have our z value of -2.0, and I can add 0. So we come here, we look for -2 on this side because that's the two that we're looking for. And then we look for a 0 at the end, which is that from them. And we find that the p-value is 0.0228. And with that, it means because we have two-sided tests, we're going to find the p-value on both sides. So we know that it's 0.022. It's also 0.0228 on the other side. So to find the p-value, and in order for us to make a decision, because it's a two-tailed test, we have to add both of those together. Or we can say it's 2 times the p-value we found on the table. And that gives us 0.456, which is 0.5. And we know that if the p-value is less than alpha, we reject the null hypothesis. And the p-value is less than and equals to 0.05. Therefore, we reject the null hypothesis and we conclude to say that the null hypothesis is the same. So you can reach the same conclusion based on the two values. And that's how you do the null hypothesis with the p-value, or making decision with the p-value. So the first one I showed you was using the critical value and the z-stat. And this one is using the p-value and the value of your alpha. Can you please switch off your microphones, guys? And please switch off your videos. Any question?
Can you please give us the answer for the exercise?
It's option 4.
Yes, okay. And is it correct saying that you will never say you accept a hypothesis? It's
Yes.
either you reject it or you don't reject it.
Yes. Yes.
All right.
Okay.
And when doing these tests, there are 2 ways in which you can do it. You can either use the critical value or the p-value.
Yes.
Can you choose which one to do whenever?
No, you cannot choose which one to do whenever, because if you look at the options that they give you, you will have to use what they've given you. Sometimes they will tell you your p-value is this and you reject the null hypothesis. Therefore, it means they require you to use the p-value to make your conclusion. Yeah. On this one, because they only were interested in the critical value, if we look at it, let's go, we came back to this one. So if we look at this, it says, state your null hypothesis and an alternative. They will already have given it to you. Sometimes they will give you the null hypothesis and the alternative. The only thing you need to always remember is to look at the sign of your alternative. And with that, it tells me that I am doing a two-tailed test because it says it's not equal. And if that's so, therefore it means option number 1 is correct. Remember, we're looking for the incorrect one. And then step number 2 was to state what you are given. So I know that my n is 20 and my alpha is 0.05, because then if I know that, I'm also going to do a z test. And if I'm doing a z test, it means I know where to find my critical value. And because my alpha is 0.05, when I go find my critical value, remember, that will be z of 0.0250 after we've divided alpha of 0.05 by 2, and this will give us 1.96. Therefore, that is the correct one. And then the next step, this was supposed to be for the critical value. Step number 5 was to calculate the z statistic. So if you would have calculated the z statistics, can you please switch off your microphone? Z is equals to, we know that our sample mean is 58 minus our population mean, they always give it in the hypothesis, so it was 55, divided by the standard error, which is the population standard deviation of 12, divided by the square root of n is 20. Calculating the standard error, which is your standard error, which is the square root the population standard deviation divided by the square root of n, which is 12 over the square root of 20. If you calculated that outside, it would have given you, and you should leave it at 4 decimals because they have it at 4 decimals. It would give you 2,6833. And therefore, then that means it's correct. And you come here, you can just substitute. 58 minus 55 is 3 over 2,6883. And if you work this one out, you will find that it is 1,1108. Because 3 divided by 2,6883 will give you 1,1180. And then we come and we make a decision. When we make a decision, remember, it's a two-tailed test, 1,96. This is the negative side, and this is the positive side of the critical value. And where does my 1,11964 fall? If it falls on this side of the area, I'm going to reject. And if it falls in the middle, I'm not going to reject. And then it falls somewhere there in the middle. I don't know where, but it's somewhere in the white area. Therefore, I do not reject. It falls in the do not reject area. And this says H naught is rejected. Therefore, this is the incorrect one because it should say H naught is not rejected at alpha 0,05. And that's how you're going to answer the question in the exam as well when it comes to hypothesis testing. And we were supposed to take a break at 10:02. We're not going to take a break. I am sorry for those who thought we're going to take a break now because this is too condensed. I'm going to just continue from here. So that is one way of doing your hypothesis testing when you have the critical value, because this one we use the critical value. If we were using the p-value, it means we will take the test statistic of 1,1180. We will go to the z-test and look for 1,12. So if we were going to use the p-value, we will use 1,12 because that our z will be 1,112, and we will go to the positive side of the table and go find the p-value on there. But because we will be looking on the positive side, we will have to subtract from 1 because we're not looking at the bigger side. And you will use that to go find your p-value, and you use the p-value to subtract, also to make your conclusion. But on this one, they are not asking you to use the p-value. So let's look at one other example where you use the p-value. So let's say, for example, I hope I have an exercise here. So here is the exercise. It says, suppose the p-value in a one-tailed test is 0,92. If that is the probability in a one-tailed test, what will be the probability, the p-value for a two-tailed test for this? Can you please turn off your videos and switch off your microphones, because I cannot keep on coming back here and checking if people have switched off their microphones or turned off their videos. Can you please make sure that you turn off your video, because your videos are the ones that are weighing on the bandwidth of this video that we are trying to record. Can you please make sure that you turn off your videos? We don't want to see your places. We also don't want to see your faces. So just make sure that every time you come in to attend any of the session, you turn off your videos. You mute your microphones so that then you don't disturb other people. Can we please respect others in that manner, to switch off and turn off our videos? Okay, so how do I answer this question? My p-value for one tail is that. My p-value for two tail, it means it's 2 times my p-value that I have, because it's a two-tail test, or you can say it's your p-value plus your p-value. So you're going to add it twice. to find the answer for this option. And do you have your answer? Yes, and that will give you option number 3, because then it is that value multiplied by 2. And that will give you 0.0184 as according to your options. Okay. Do you have any questions? Any question? If there are no questions, then you have another exercise, but I'm not going to go through this exercise and the other one, you can also do, the handouts are in the files folder on the channel. You can download the files and do them. We're supposed to start at 4 and look at hypothesis testing for T, or where the mean, hypothesis testing for the mean when the population standard deviation is unknown. When the population standard deviation is unknown, it means they would have given us the sample standard deviation, and therefore it means we're going to be using the t-test. And remember also the steps that we need to follow of the 6 steps of hypothesis, it will also apply on here. So let's look at this example. When we have a two-tailed test for where the population standard deviation is unknown, and we are given here that the average cost of the hotel in a room in a New York, it's 160, in a New York hotel, it's 168 per night. To determine if a true random sample of 25 hotels are taken, and the result shows that the mean of 172 and 50 and the sample standard deviation of 1540, test the appropriate hypothesis at alpha is equals to 0.05. So they have given us the sample standard deviation. Therefore, it means we're doing a t-tail test. And we are told that the mean is, so it means it is equal, so the alternative will be not equal. So if we state the null hypothesis and the alternative hypothesis. So we know the 6 steps: state the null hypothesis, alternative, choose what you are given, define the kind of test you're doing. Now we know that we're going to be doing a t-tail test. Find the critical values by using the alpha and the degrees of freedom. Remember, if we're doing t-test, our critical value will have the degrees of freedom. Calculate the test statistic. We use the same as the sampling standard deviation, sampling distribution formula, the test stat. But since we're not given this population, we're given the sample. Instead of the sigma, we'll use the S. And then we make the conclusion, the decision, and then we conclude. So for a two-tailed test, same. Step 1, we state what you are given, your null hypothesis and your alternative hypothesis. The mean is 168. The mean is not 100. The mean is 168. Alternative, the mean is not 168. State what you are given. Alpha is 0.05, n is 25, and we can also just calculate the degrees of freedom because we would use it. What kind of a test we're doing? We're going to do a t-tail test. We can go find, because the population standard deviation is not given, so we're going to find the t-test. The critical value, T alpha divided by, let's go back, T alpha divided by 2, and the degrees of freedom, we know that T alpha of 0.05 divided by 2, and the degrees of freedom is n minus 1. So our degrees of freedom, we calculated it and we found that it's 24, it's fine. So therefore it means our critical value, we're going to find it on T 0.0250 and the degrees of freedom of 24. We go to the T table. Okay. We go to the T table. And this is our T table. We go look for T 0.025, somewhere there at the top. And then we go to look for degrees of freedom of 24, somewhere on here. So let's go. There is the T, and then we go look for degrees of freedom of 24, where they both meet. And that is our degrees of our critical value, 2.064. Now, I need to also say this. As some tables are 4 decimals, some tables are 3 decimals. So you must use the critical value as per your module. So for example, on this past exam paper that I'm using right now, the critical values here are 3 decimals. You might find that on 1501, your critical value might be 3 decimal or 4 decimal. So yeah, it's 3 decimal, it's fine. For 1510, your critical values might be different, might be 4 decimals. And your critical values are 4 decimals, so you will use the 4 decimal table for your, when you answer your question on your exam paper. As you can see that they are different. And for STA 1610, it's the same as the one that I'm using, the XTA, because they are one and the same, they write the same paper. So this is 3 decimals. So depending on your module, you must use your table. So for example, on this one, the critical value is 4 decimals, so it means I might have used and our critical value okay, I cannot remove that now. And then we define, based on the critical value that we got, we define our rejection area. And we can see, because we're doing a two-tailed test, we'll have 2 rejection area. And because it's a rejection area, we will have the negative side and the positive side. And then we calculate our test statistic. And when we calculate our test statistic, because we know that we're doing a t-test and our sample standard deviation was S, we substitute the values. The mean of 172.50 minus 68 divided by the standard error, which is 15.40 divided by the square root of 25. And that gives us 1.46. And when I have that value, I can now go and do or find where it's located on the critical value or the or on the rejection area. And therefore, it falls here. And where it falls, it means I can make my decision and conclude. Sorry. And therefore, because it falls in the do not reject area, let's do this. Let's discuss all the ink, because then it disturbs, it's shadowing everywhere. Our 1,46 falls in the do not reject area. Therefore, we do not reject the null hypothesis because the mean is, there is insufficient evidence that the true mean cost is different from 168. It's not different from 168. And that's how you make decisions. If we have a one-tailed test, therefore it means, for example, with this, a phone manager or a phone industry manager thinks that the customer monthly bill phones have increased, and now he thinks that the average, it averages over 52 rand per month. The company wishes to test this claim, and we assume that the population is normal and our N is 24. So, and as we go along, I will make up the alpha and I will give you the values that are needed, like your standard deviation and so forth. Don't ask me where they are. They are they in the question. They will give it. They will give them in the question, so they won't be asking you to make it up as you go along. So we assume that everything they've given us, we know that we're not doing the population standard deviation is not given in this instance. We are given the sample standard deviation. To state the null hypothesis, we say the mean is over. Because of that over, it means our alternative will say the mean, the population mean, it's greater than 52, because we cannot put greater than in the null hypothesis, because then the null hypothesis always has an equal sign. So the mean is greater than or is over 52 rand per month. And then we go and do and test our claim. So we state our null hypothesis and alternative hypothesis. We state what we are given. So they've given us alpha of 0,10, N is 25. So the degrees of freedom is 24. We know that we're doing a t-test because they've given us the population, the sample standard deviation, not the population standard deviation. We go find the critical value. When we go to the table, we use 24 and 0,1. We will find that the critical value is 1,31. Now, how did I go and find this? Because I'm doing a one-tailed test, therefore it means my critical value is alpha, not alpha divided by 2. It's alpha and the degrees of freedom. And my alpha is 0,10 and my degrees of freedom is 24. So I don't have to divide my alpha by 2. So it's just the alpha and 0,024. And then when you go to the t table, you will find that it's 1,318. And then it will define your area of rejection, which is that. It will tell me if it falls on this blue shaded area, it means I'm going to reject the null hypothesis. If it falls in the white area, I do not reject the null hypothesis. And then I go and calculate the test statistic. And when you calculate the test statistic, the mean is 53, and you substitute into the formula, and you will get that the test statistic says it is 0,55. And with that, when it's 0,55, we go back to the diagram where we had our rejection area, and we go place our test statistic, and we find that our test statistic falls here. It falls in the do not reject area. Therefore, it means we do not reject the null hypothesis at t 0.05 is less than or equals to 1.318, then there is no sufficient evidence that the mean bill is over 52 rand. And that's how you make decisions for one-sided tests. And with that, you have an exercise to do. Remember, if we're going to test at 95% confidence interval, step number 1, state your null hypothesis and your alternative, which they already did. Step number 2, but you just need to state whether is this a one-tail or two-tail with using the null hypothesis and the alternative. Step number 2, state what you are given in terms of n and alpha, and maybe also degrees of freedom. You can calculate them. Step number 3, what test are we doing? What test statistic is this? Statistics is this. Step number 4, find the critical value for T. And based on whether you're doing a two-tail or one-tail, how do you find the critical value? Is it T alpha or is it T alpha divided by 2 with the degrees of freedom? You need to choose which one it is and use the right one. And then step number 5, you need to calculate. You need to calculate the, because we're doing a t-test, so I am going to just do the test stat, which is your mean minus the population mean divided by your sample standard deviation divided by the square root of n. And then step number 6, you make your conclusion. Based on where did you define your critical areas? So define your critical, using the critical areas, define where your decisions are going to be made by defining your area of rejection based on that. And then after that, you can take the answer for that and make your decision and then conclude. And those are the steps I am looking for.
Sorry, ma'am, can I ask a question?
Yes, go ahead.
On the question, we're given standard population standard deviation. So shall we do it as sample standard deviation?
You are not given the population standard deviation. Where does it say the population standard deviation?
It
You
says
are given, nope, it says in a random sample, the mean is that and the standard deviation is that. Where do you see the population standard deviation?
okay, thanks, I get it.
Cool.
Looking here, that's why it's been talking on I say it up here. I sent it to you.
Are you done? Since there was no options for you to answer the question, to validate your answers, so it means you might have different answers. Let's see if we all got the same answers. Can you see that? This is not stat, whatever the module you are doing. Here we're doing ACALIT. It's not based on which chapter of the thingy is. I just pick complex complex components, and I'm just taking you guys through them to make you understand them much better. So we didn't cover the entire module that you are doing, so I'm just picking some of the components, and I'm not covering everything, so do not be stressed. And we will not be doing any exam papers or exam preparations here. We're only doing the content, and then other discussions can happen outside of the Teams forums. There is a session plan that we follow based on the agreement I had with UNISA. So I am sorry that today is your first time, but you will catch up. Don't worry. Okay, so let's answer this question. Let's see if we can attempt to answer the question. Okay, so I'm gonna use a blue marker. So our null hypothesis and alternative hypothesis are stated. Whether are we doing a two-tail test or a one-tail test. Looking at our alternative hypothesis, I can clearly see that we're doing a one-tail test. We're doing a one-tail test, therefore it means we're going to have one rejection area. And then what we're given, we are also given that whether the average night workman is 12 minutes, and that's what they have told us there, with the mean, which is the population mean of 12 minutes. And they say from a random sample of 24, which means from this sample of 24, they calculated that the average, which is the mean, which is your X bar, is that, and they calculated that your standard deviation, which is your S, will be that, because they come from that random sample. If it was from the population, they would have put it with the 12 minutes at the front, or they would have stated it and say a population standard deviation of outside of the sample. So because this, we read it in one sentence with where the sample for the meaning of that, with the standard deviation of that, therefore it means whatever we're looking here, it's all related to that random sample. And our N, we are told that is 24, and therefore our degrees of freedom will be 23, because it will be N minus 1, which is 23. And our alpha, we are told that we must do it at 95% confidence level, therefore our alpha here is 0.05. Our test, we're going to be doing a t-test statistic, because we are given the sample standard deviation. Finding the critical value, T alpha, because it's a one-tail test, our alpha is 0.05, and our degrees of freedom is 23. It's 23. Then we go to the T table. We go to the T table. And we come to the T table. And we look for 23. And remember, we're not interested in the values at the top. Those values on the T table, we're looking for 0,05 there. Remember, it's T 0,05. And the degrees of freedom, I don't know why it's blinking, of 23. So we look for T, 0.05 here. And we look for 23 degrees of freedom, 23, and where they both meet, that will be our critical value. And our critical value is 1,7139. So if you are using the other books, you will get 1,714. If I go to the critical values, 23, so you will go to 0,05 and you will see that you get almost the same answer, which is 1,714 or 1,739, depending on which module you are using. And that's our critical value. And our critical value will be 1,7139. And then you go calculate the test statistic. I haven't calculated the test statistic, so I'm assuming you already calculated the test statistic. You know what the answer is. I'm just going to populate the values. So our sample mean is 12,57. 12,57 minus our population mean was 12. Divide by the standard error, which is 1,23, divide by the square root of our population, which is 24, or our sample, which is 24. And did you calculate? What did you get? Have you guys calculated this?
Yes, it's 2.270.
2.270. So if it's 2.270, and we know we want to make a decision, our critical value, we can define it because it's on the upper side. We can define our critical value at that point, which this is T alpha, which is equals to 1,7139. And this is our rejection area. And looking at that, where does it fall? Our 2,70 will fall. This number will fall somewhere here, and therefore it falls in the rejection area. Then we can conclude that we do reject the null hypothesis at alpha 0,05 because there is sufficient evidence that the mean is greater than 12. It's more than 12. And that's how you make decision on the hypothesis testing. Yes, Kai? You reject the null hypothesis. Yes. Yes, yes, yes. And that's how you do that. So you will see that also. For example, this is one of the question from the past exam paper. I don't know which book, which module, but it's one of the past exam paper. So you will get a question that looks like this and says a random sample of 10, which means our n is 10, was drawn from a normally distributed population. The data values were, and then they give you the values of that random sample that they got. They give you their data values. So it means on here that they want you to do something. The other thing that they give you is the following. They tell you that the population mean is greater than 6 for the null hypothesis, and the alternative they give you is less than. So you already can see what kind of a test you're going to be doing here. And then the other things, you will be getting them as we go along. as part of the question. For example, based on the sample, if I read all this, there should be 10 of them. 6 plus 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are part of the sample. So from here, I should be able to calculate the mean. I should be able to calculate my sample standard deviation from that. But the question here says the sample mean. Remember, the mean, the sum of all the observations divided by how many there are. And yet it says the variance. The variance is S squared because they are not looking for the standard deviation, but they are looking for the variance. The sample variance will be the sum of your X observation minus the sample mean squared divided by N minus 1. And that's what you're going to be doing to go find this. And check if that is equals to 1, then it will be the answer. Then they also ask you to calculate the rejection area. So here they want you to go and say, what is your critical value? And you go find your critical value. Is this your critical value? For when it is less than. So remember the rejection area for the less than will be on the side. But is that the value that we're going to be using for the T alpha and the degrees of freedom? Because then it means you're going to go find T alpha degrees of freedom, and they already gave you what your degrees of freedom is. But if you look here, that they made a mistake there because they used 10. They should be saying alpha is 0.05, and then the degrees of freedom will be n minus 10. But because they gave you this, so you need to use the values that they give you, because I am not sure what the thinking was from there, because they are looking for the correct answer. So looking at that, it says T alpha 0.05 and 10 should be giving you that. So that's what they want you to do, but I will assume that was supposed to be 9, not 10, n minus 1. And then they also want you to go calculate the test statistics. So it means they want you to calculate T is equals to the mean minus the population mean divided by the sample standard deviation divided by S over the square root of n. Now, since you calculated the population, the sample standard deviation or sample variance on there, therefore it means to calculate S, you just take the square root of X squared. Of that answer, you take the square root of it. But depending that it equals to 1, you can take the square root of 1, but I don't know. So you substitute the value of S by finding the standard deviation and solve this to answer option number 4. Option number 5, they're asking you, are you making any decision? And in your decision, are you rejecting the null hypothesis? Based on the information that you collated from all those, because this says it's also there, it says it's positive, and here I can see they put the negative. So you need to make up your mind, what is the T value here? And if your T value was negative, is this the same as if you would have made up your decision there by going back, by finding the critical value, which you would have done there in number 3, and finding the test statistic, which you would have calculated there. Does that give you this answer? Are you rejecting the null hypothesis or not? So you need to be able to know all the 6 steps of hypothesis. That's one question that looks like that. Okay, and that is T. Let's look at the proportion. You have any other question? If no questions, then we can go and look at the proportion. Okay. The last one that we need to do is finding the hypothesis or calculating the hypothesis for the proportions. And if it's the proportion, we're going to be using the z-test, and we're going to use P, which is the sample proportion minus the population proportion divided by the standard error. And all assumptions need to be met. And you can see that what you do not cover in your modules is the other part that you, like where the population, your expected mean is less than 5, or where it's for the expected mean of the inverse is less than 5. You do not cover that. You only cover one part of it for the proportion where the population is normally distributed with the expected mean of more than 5. Remember, for the proportion, they might give you observation satisfying the sample proportion. You need to be able to calculate P by taking X divided by N. That will give you your sample proportion. So similar, let's look at an example for doing a hypothesis testing for the proportion. And remember, the proportion, like we did with confidence interval, proportions are like your percentages or the decimals, like 0.08, or they will give you and say 60% of the population is this. And that you will know that you're doing the proportion. So 8% of the responses that they claim comes from mailing. To test this claim, a random sample of 500 were surveyed, with 25 of the people responding to this survey. Test at alpha 0.05 significance level. So we need to test this claim that this marketing company claims that 8% of the responses comes from the mailing, not somewhere else. So what are we given here? And we can check all these are met. There are more than 5. So we are given the population proportion. We are given our N, which is our sample size. We are given our X, which is the observation satisfying that sample. And we are also given alpha. Then we can calculate or do our hypothesis testing. Like with any other hypothesis testing, you must always remember the 6 steps. State the null hypothesis or alternative. What are you given in terms of alpha and N? But with this, you will also be given the X observation, so you can also calculate the P at this point. You can also calculate your P because sometimes they are not giving you P. So you can just calculate it because we know that it's X over N. And you can calculate it from here as well. And then you can determine what kind of a test statistics you're doing. It's for proportion. We're doing a z-test. You go find the critical value. Because it's a z-test, we go find the critical value on the Z table, not the T table, on the Z table. And the critical values, depending on also whether it's going to also determine the rejection areas. So based on the null hypothesis, is it a 2-tail or is it a 1-tail or something like that? So it will depend on your null hypothesis, your alternative hypothesis sign. And then we calculate the test statistics. This would calculate the test statistics for the proportion, which is your Z is equals to the sample proportion minus the population proportion divided by the standard error. And then you can use your rejection areas to make a decision based on your critical value and the Z-test. If your Z-test falls in the rejection area, you reject. If it falls in the do not reject area, you do not reject. And make your conclusion. So let's look at an example. Let's say with that one that we had where the mean was 8%, the population proportion was 8%. So we state our null hypothesis and our alternative, which is the first step. Null hypothesis alternative, the population proportion is 0.08. Our alternative population proportion is not 0.08. what we are given. We are told our alpha is 0.05. Remember, we are given that 25 divided by 500, and we divide the p will give us x divided by n, which was 25 divided by 500. I hope I am right there. Where is my calculator? Okay, I lost my calculator. Okay, I hope it is the same.
It's correct. It's 0.05.
It's 0.05. So 25 divided by 500 is 0.05, which is our P. And then we're going to be doing the Z test because it's for the proportion. And then the next step is to find the critical value. Because our alpha is 0.05 and it's a two-tailed test, I don't have to go and repeat all this, guys. Even when you go write the exam, by the time you go write the exam, you will know that for alpha divided by 2 for a 5% level of significance, by this time you should know that it is 1.96. You don't even have to go scratch your head and all that. Only for the Z critical value, you need to know that, because they always like using alpha of 0.05 or 95% confidence interval. Okay, so we can then label our rejection areas. Because it's 1.96, our critical value, so our rejection area, and because it's a two-tailed test, it will be and our rejection area, because it's a two-tailed test, it will be on two sides. Then we calculate our test statistic by substituting the values. Our sample proportion was 0.05 minus our population proportion, which is always stated in our null hypothesis or our alternative hypothesis, is 0.08. Then we substitute the values for the standard error, and we find that it's 0.08 times 1 minus 0.08 divided by 500, and we take the square root of that. And if we solve all this, we find that our Z is equals to minus 2.47. And that's where the Z is. It falls in the rejection area, and we can make our decision that we're going to reject the null hypothesis at alpha 0.05 because there is sufficient evidence to reject the claim of 8% response, because our Z statistics is less than our critical value of minus 1.96. And that's how you make the decision. So you will see that all the steps are just the same for all the hypothesis testing, whether you're doing for the mean or whether you're doing for the proportion. Also, for the proportion, you can also use a p-value to make a decision. So on this one, remember we were using the critical value and the Z value. We can also use the p-value. So we take the value of our p-value, which is minus 2.47, and we go it on the, we go to our Z table. Go to the Z table. On the Z table, we go look for minus 2.47 as a critical, as our Z value. Remember our Z, it said it's minus 2.47. So we go find 2.4, and then we go look at the top for the last digit of 7, which is there, where they both meet. Sorry, my hands, and it's 0.068. So we go 0.068. Oh, come on, sorry, right. So it's 0.068, but remember it's two-sided. So it means it's multiply that value by 2 0,0268 multiplied by 2, and that will give us 0,0136. And remember, if p-value is less than alpha, we reject the null hypothesis. That is the decision. And we know that our p-value is 0,0136. Therefore, it is less than alpha of 0,05. And then the decision we take is we reject. The same way as we rejected the null hypothesis, if I go one back, we rejected the null hypothesis when we were using the critical value and your z-test. It's the same even when we're using the p-value and alpha to make the same conclusion. We get to the same conclusion. And that concludes what I wanted to tell you. And with that, we have 9 minutes. We're not going to get to the exercise. So let me take you through the exercise and you can do them and we can discuss them outside of this forum. We can discuss them on WhatsApp if you want. So the first one, a random sample of 200 physicians shows that there are 36 men who make at least 6 million a year. Can we conclude that 1% at 1% significance level that the true proportion of physicians in this population make at least 6 million a year are less than 0,24? Now, what am I given? A sample, which is my n of 200. I am also given my x, which is 36. I am told that the population, which is my mean, my proportion, my true proportion of this population, the true population is 0,24, but I'm also told there that it is less than. So therefore, that's less than. The first step is to state your null hypothesis and your alternative hypothesis. That's what you need to do. What is your null hypothesis? What is your null hypothesis? And what is your alternative hypothesis? That's the first step. The second step is asking, state and calculate the appropriate test. And you will need to state the appropriate test is the z-stat. And then you will know that it is the p minus the divide by 1 minus divide by n. Now, if you are doing 1501, because I think this comes from your module, remember that your z-stat, we will get to that at the later stage, but remember that where we use the proportion, I forgot to mention this earlier when we start, it is your capital letter P. Where we use the P, remember that yours, you use the P capital. But it's the same, so you will just substitute with the right P's where it's suitable. Then C is asking you, what is your critical value? So it means, what is your Z critical value? We're doing a one-sided test. So it means you're going to find only your critical value with using Z alpha because of that one-tailed test. I'm saying it because I need to give you guidance. So it says determine the critical value of this. That's what they want you to go find. So you will use alpha of 1% and go find the critical value. State whether or not you reject the null hypothesis. So it means based on the test statistic and your null hypothesis, can you please switch off your microphones, guys? Based on your Z test statistic and your critical value, you can make your decision. So your critical values, and this because it's a one-sided test, therefore you're going to go find your critical value and define what your critical value, Z alpha, it was coming all right, now it's doing what it wants to do. Based on this, going to define what this critical value is from C, and based on the test statistic that we have, where does it fall? Does it fall in the rejection area, or does it fall in the do not reject area? And that's what you need to be stating there, that you are rejecting the null hypothesis based on Z stat is less than your Z critical value, because that will say Z stat is less than your Z critical value, therefore you're going to reject the null hypothesis if it's so. If it's not, then you will say your Z stat is greater than that, you do not reject the null hypothesis. And you make your decision. Based on what you are doing there, when you are rejecting or not rejecting, then you can make a decision and say the true proportion of the does not make less than that, or it makes that. Because then based on the statement you put on your null hypothesis, you can make your conclusion based on that. Okay, so that's how you're going to do exercise 1. Exercise 2 is the same. What am I given? I'm given the population proportion, which they also define there, my null hypothesis and my alternative hypothesis. Now, is this a two-tailed test or a one-tailed test? Because if it's a two-tailed test, then what will be my p-value when I get the p-value? But before that, we can start here. They are asking you for p. This p, they're asking you if it's x divided by n. Where do we find my x? There is my x and there is my n. And you're going to find your p and see if it's the same as that. So this will be x divided by n should give you your p. The standard error, because this is for the proportion. The standard error, remember the formula for z, it's p minus the population proportion divided by the standard error. And this is the standard error, divided by the square root of n, z. They want you to go calculate this. This is oh, come on. This is what they want you to calculate. The one only at the bottom, which is your standard error, will be just the square root of that value inside the bracket. That will answer that question. The test statistic, you need to solve the Z value and find which one of them is correct. Remember, the statement is looking for the correct one. For the p value, based on the value of your null alternative hypothesis, what are they asking you to do there is to go find the p-value. Remember, if the p-value is that, what do we do on the normal distribution table when we go find the probability of Z greater than A? You still apply the same method that you do. So that will give you the probability of Z greater than A, because you're going to be finding the value of Z, which you calculated there. And that will be the probability that you need. You will still go and find 1 minus the value you find on the table. You still apply the same concept that you learned when we were doing the normal distribution and the sampling distribution. Based on that, it will give you your p-value by subtracting the value you find on the table from 1. Now you need to make a decision. On here, they didn't ask you to go find the critical value. So therefore, it means the decision they want you to make here is based on, so this decision is based on alpha and the p-value. So you're going to use p-value. If it's less than alpha, you're going to reject the null hypothesis. Otherwise, you do not reject the null hypothesis. They've given you the value of alpha, so you're going to use that value of alpha and the value of the p-value that you calculated there to make that decision. And that's all what you need to do on this exercise. Let's see if we're still on time. We are 1 minute on time. And you can also do this exercise. I'm not going to give you hints anymore. You can go and sort it out yourself on how you solve this, because you can see that this is also taking you through all the 6 steps of the hypothesis. They're asking you, reading that statement, is this the correct null hypothesis and alternative? Is this the way you state the null hypothesis and the alternative based on the information they have given you? They also ask you to calculate the test statistic, which you can calculate. It's Z. It's the same as the test statistic that we have there. Step number 3 and 4. One is asking you to calculate the critical value. So you need to go find the critical value on the Z table using 10% as your alpha. So because you go into Z, you're going to go find Z alpha. And that is if this is the right alternative hypothesis. Otherwise, if it's not, if the question is a two-tailed test, remember you're going to do alpha divided by 2. The same with the p-value. If this is not correct and it should be a not equal, not that, because you are going to state whether that is correct or not. If that is a two-tail, remember if it's one tail for p-value, one tail is the p-value is the value you find on the table, depending, because it's less than, if it's less than, then it's fine, is the value you find on the table. If it's a two-tail, it's 2 times the p-value. That will be the value you find on the table. So depending on your null hypothesis and alternative, number 3 and number 4, they ride on it. And number 5, because based on that, you need to state whether you are rejecting the null hypothesis or not. And you can choose. Now here you can choose either one. You can choose to use the test statistic or the alpha, but it's up to you. Because based on the test statistic that you got there, you will have the value of your alpha. So here you can use your Z stat and your critical value, your Z critical value to make a decision, or you can use your p value, which based on the alternative, how you define your p value, alpha divided by 2. Oh, sorry, alpha, and therefore you're going to reject. And so also depending on the Z stat and the critical value, so I don't know whether it's a two-tail or a one-tail. Based on that, you will need to make sure that you have the right critical value, because if it's a two-tail test, it means you have 2 sides. If it's a two-tail, remember you have 2 sides. You will have a 2 side if it's a two-tail, if it's Z alpha divided by 2, Z in the negative, Z alpha divided by 2. If it's a one-tail, and if it's that it's correct, therefore it means you only have 1 side, which is Z alpha, to make that decision. Or you make use of the P and the alpha to make your decision. And that's all what I had for you for today. If we recap on what we did, we looked at performing the hypothesis testing for the mean when the population standard deviation is given, and we looked at the p-value, how we can make a decision based on the critical value and the p-value approach. We also looked at how we can calculate it based on the one-tail test, on the two-tail test. We did several examples in that manner. We also looked at performing a t-test for the mean where the population standard deviation is unknown, and also for the z-test for the proportion, and that was the last session that we did. In terms of the other information that you just need to know, I've also included them there, which you can read about, because they sometimes ask you in the exam to just state what they mean as part of the option. So you just need to know what critical value is and what a two-tailed test mean and what the type 1 error is and all those things. And then last but not least, this is to help those who are doing 1501. Remember where we talk about the proportion, and you must know how you state your proportions in terms of your formula, your capital letter P or your P cappies. Otherwise, those are the samples, T statistics, and these are the formulas you will get in the exam anyway. They will give them in the exam. You just need to know which one calculates what. And that concludes today's session. Any question? Any question? If there are no questions, thank you for coming. Please remember to complete the feedback form. And I will see you next week, Tuesday, on